as is pretty typical for North American math textbooks, the first chapter is an obligatory review chapter, pretty much. So, basic mathematical operations. You can always use a 4-step plan to solve a problem. You explore what is given and what is required. You select a strategy, maybe make an estimate. You solve the problem by doing what you plan to do, and then you check to see if your answer seems reasonable, or you work backwards and basically just do the problem in reverse and see if you get what you begin with. So, this is also given in some other places as grasp, which is given, required, analysis, solve, or analyze and solve, and then present. Present is basically state your answer. This is really relevant if it's a word problem where you're supposed to have a statement at the end. The solve part includes checking in the grasp version. But here it's presented as explore, plan, solve, and check. Presumably to emphasize the checking, because a lot of people for some reason don't do it very often. Oh well. So here we have plant A and plant B. They're two new experimental apple trees being grown in a lab. The table displays their height in millimeters when they are 5 to 10 days old. Estimate the height of each plant on day 12. Well, we explore and we see that plant A is plus 3 millimeters per day. It's very visible. 36 to 39 is plus 3, 39 to 42 is plus 3 again, plus 3 again, and plus 3 again. Whereas plant B increases by 4 millimeters a day. Visual inspection can reveal this, because I don't think the 40 to 44 transition is exactly hard to spot. So, estimate the height of each plant on day 12. Plant A is going to be at 51 plus... This 2 is because it's 2 days from 10 to 12. Of course, depending on how precisely your teacher wants you to present all your steps, you might have to put 12 minus 10 instead of 2 here. So 51 plus 2 times 3 is equal to 57 millimeters. And B is at the observed trend. It's going to be 52 plus 2 times 4 millimeters. So 2 more days of growth at 4 millimeters a day brings us from 52 up to 60 millimeters. Okay. And our statements would be, on day 12, plant A. On day 12, plant A is predicted to be 57 millimeters tall, and plant B 60 millimeters tall. So your statement should essentially restate the last bit of the question with the answers included. In this case, that's this part. The height of plant A on day 12 is 57 millimeters. And height of plant B is whatever it is, In this case, 60 millimeters. Yeah, that's one way you could state it, but here it's grammatically a little bit less curious, shall we say. So let's use a 4-step plan to solve each problem. Suppose a movie ticket costs $10.50, a large popcorn costs $4.25, and a large soda costs $3.25. How much will it cost two friends to go to a movie if they share a popcorn and each has a large soda? So we have 2 tickets at $10.50 each, 1 popcorn at $4.25 each. Well, in this case, there's only one, so we don't need to put each. And 2 sodas. This is at $3.25 each. So this is the given part. The required is total equals what? Question mark. And explore, plan. Well, okay, it's pretty obvious what we have planned. You multiply these things and add them up. Solve. 2 times 10.50 plus 1 times 4.25 if you want to be showing everything. I show specifically that there's only 1 popcorn. Plus 2 times 3.25. Yeah, this is our plan. And we solve, which gives us 21 plus 4.25 plus 6.50. So 0.75 at the end. And then 10 plus 21, so $31.75. Yes, I know this dollar symbol maybe at the front, but whatever. Everybody understands this anyway. So, check. Is this reasonable? Now we know that each soda costs a bit over $3. And a popcorn costs a bit over $4. There's 2 sodas and 1 popcorn. Total is going to be a bit over $10. A movie ticket costs $10.50. So 2 movie tickets is going to cost you $21 plus $10. Oh, $31. Yeah, okay, it's a bit over $31. Wonderful. So it's reasonable. And of course, in the other method, we have a state at the end. So it costs them. Notice how your statement can be very summarized compared to the last bit of the question. Like you could write, it will cost 2 friends this much to go to the movie if they share a popcorn and each has a large soda. But why? Why? Yeah, no. So it costs them $31.75. Okay, dollar symbol usually goes in front. Fine, whatever. That's it. Short statement, huh? That's why sometimes we just skip the statements altogether when we do questions here, because y'all probably don't want to see me writing too much on the board. Okay, suppose a population of mice is limited to doubling every 4 weeks for the foreseeable future by predation. Yeah, mice have large litters. Like, they have a lot of offspring at a time. And they can breed roughly every 4 weeks-ish. Depends on the rodent. Some actually breed remarkably few times a year. Huh. But there are plenty that actually breed faster than this, like more often than once for every 4 weeks. But I know it takes about 3 weeks for baby mice to be weaned, i.e. to no longer get milk. So let's say 4 weeks is this population of mice, fine, doubling every 4 weeks because enough of them are getting eaten to prevent it from being any faster. How long would it take for the population to grow to 8 times its original size? Yeah, this is math, guys. So in other words, we aren't restricting this growth by, say, limited food supply or the fact that the predators eventually wise up and more of them show up to take more mice. So, how long would it take for the population to grow to 8 times its original size? 8 times equals 2 by 2 by 2. So it's 2 to the third power. And doubling every 4 weeks. Every 4 weeks. So in 4 weeks, you have twice as many mice as you started with. In 8 weeks, you have twice of twice, i.e. 4 times. And in 12 weeks, you have 8 times the original size. So 3 cycles of 4 weeks needed. Yeah, our plan is basically to find how many cycles of 4 weeks do we need. And this is our given information. And our required is how long it takes for the population to reach 8 times its size. You could write that here if you're going strictly by the 4-step method given above. But yeah, here's the plan, here's the solution. I'm basically saying it, most of it. And that means 3 by 4 is equal to 12 weeks. So it will take 12 weeks. There's our statement. Variables, expressions, and properties. When you're finding the value of an expression that has more than one operation, i.e. you have, say, add something and then subtract something, you follow the order of operations. You start with brackets, so grouping symbols. They can also be called parentheses. You start with the innermost grouping symbols. Usually, if you have nested brackets, you have something like this. And depending on convention, you may use brace brackets as a third level of brackets. However, in other places, brace brackets are only used when you're giving large sets of equations or something. Or set notation. So brace brackets may vary in usage. But if you have more than 3 levels of nesting, or if you're doing computer code, just using round brackets is generally okay. So, you start with the innermost grouping symbols. That means you do this part first, and then you do this, and then you do the rest. And then whatever's outside. Now, you evaluate powers before other operations. Why? Well, let's say a is equal to 5 times 3. Well, what's a to the third power? Well, that's equal to 5 times 3 to the third power. In other words, if you have an exponent on something, be it a variable or a number, that's like saying it's an exponent of whatever that thing represents. With the representation, if you substitute it in, functioning like a bracket. Like that's a priority here. Okay, so after you do this, you have to multiply by itself however many times before you do anything else. So multiply and divide in order from left to right. And then you subtract or add in order from left to right. So there are many different acronyms that have been coined over the years for this order. The one that I'm most familiar with is BADMAS. So let's evaluate this expression here. Well, we solve the brackets first, which gives us 5 plus 7 is 12, divided by 2 times 3 minus 9. So 12 divided by 2 is 6. And then times 3 is 18 minus 9, which gives us 9. Okay, let's evaluate this expression. 3x squared minus 4y if x is equal to 3 and y is equal to 2. So we substitute in, and that gives us 3 times 3 squared minus 4 times 2. So that's 27. Why is it that I can do this in one step if I deem it necessary? Guys, these two parts of higher priority operations, i.e. multiplications, they're separated by a subtraction sign, a lower priority. And here it's 3 times 3 times 3. That's not exactly something that should require more than one step at this grade level. Like 3 times 3 times 3, it's 3 times 9. If you remember your times tables, there it is, 27. Minus 8. Of course, if you're being told to strictly follow order of operations, yeah, okay, you'll want to add a step that goes 3 times 9 minus 4 times 2 in between, but So yeah, when you subtract this, it's 19. Okay, evaluate each expression here. 14 divided by 2 plus 3 times 5. That's 7 plus 15. So 22. 5 minus 6 times 2 divided by 3. So 5 minus 12 divided by 3. 5 minus 4. Now how about this here? 17 minus 5 over 6 plus 5. Well, you do brackets first. 17 minus 5 is 12, multiplied by 11. 12 times 11 is 132. So 3 plus, oh hey, we have brackets. That means we do brackets first. So 3 plus 7 times, and inside the brackets, what order do we go in? We have to follow the order of operations, which means multiplication and division before addition and subtraction. 14 minus 8 divided by 2 is 4. So that's 3 plus 7 times 10. So 3 plus 70. Yeah, this is the sort of thing you get if you're particularly demonstrating the order of operations. Otherwise, this would just go to 73 straight out. For this, 5 times square bracket 24 minus round bracket 6 plus 8, and then close the brackets. You do the innermost bracket first. Okay, then, what do we do with the outer brackets? Do we leave them as square brackets to show where they came from in the step prior? Or, say, at the beginning of the problem, in this case? In some conventions, yes. This is so that you can trace where this came from. Okay, that makes sense, right? In other conventions, you downgrade them to round brackets. So each has its own benefits and problems. Well, 5 times 10 is 50. Okay, what is this? Oh, hey, it's a fraction. What is a fraction? Well, it's the numerator divided by the denominator. In this case, that means 14 divided by, denominator needs to be mathed out first before we can actually do any division. Same with the numerator, though. So a fraction actually looks kind of like this if you want to expand it out into everyday notation. That's part of why people invented the fraction notation, because they didn't want to write so many grouping symbols. Well then, that's 14 over 3 squared is 9 minus 2. So 14 over 7, which is equal to 2. Okay, evaluate each of these expressions if a equals 3, b equals 5, and c equals 6. A times b squared, well, that's equal to 3 times 5 squared, so 15 squared equals 225. A times b plus c, that's 3 times 5 plus 6, so 3 times 11 equals 33. 3 times bracket b times c, so 5 times 6 minus 8. You could have gone for nested brackets where all your substitutions were inside brackets, if that's your preferred convention or what is required in your area, in which case you wouldn't need the multiplication symbol. But in this case I didn't, I went with the other way. The reason why some people use brackets around every substitution at first is because that makes it relatively easy to find which numbers were just substituted in. So 3 times 5 times 6 is 30 minus 8, and then divided by 3. You can see that times 3 divided by 3, we can cancel them out if we so desire. But since we're going with order of operations here, no, we're not going to do that. 3 times 22 divided by 3. So 66 divided by 3, which is equal to 22. Okay, so integers and absolute value. If you have a number line, you have the smaller numbers on the left, so negatives. If you have 0 somewhere on your number line, then it's negatives on the left and positives on the right. with the numbers getting bigger as you go to the right and smaller as you go to the left on your number line. So, if you graph your integers on a number line, or plot them, depending on preferred terminology, the smaller integer is always to the left of the greater integer, because the numbers increase to the right and decrease to the left. So let's say we wanted to order the set of integers 10, -3, -9, 4, and 0 from least to greatest by graphing each integer on a number line. They would look like this. 0 is here on, well, 0. -3 is over here, between -2 and -4, halfway specifically. -9 is over here. 10 is on, well, 10. 4 is on 4. Nobody's surprised, right? So if you're ordering them from least to greatest, you can do it by graphing them on a number line. You can also write them in that order. So -9, -3, 0, 4, 10. Or you can write this with -9 is less than -3 is less than 0 is less than 4 is less than 10. So there are different ways of ordering integers from least to greatest and presenting the order. You can do it graphically. You can do it by just a set of numbers that are listed this way, so just listing them, or you can use comparison symbols. The absolute value of a number is the distance of that number from 0 on a number line. If you go from 0 and you go 5 units one way, you end up at +5, but if you go 5 units the other way, you end up at -5. How far is -5 from 0? Oh, it's 5 units. How far is +5 from 0? Oh, it's 5 units. So, if you take the magnitude, that's another word for absolute value, magnitude of -5, you just take off the negative symbol and you get 5. If you take the magnitude of +5, it's just 5. So the positive number, it stays the same. The negative number, you take off the negative symbol. So -20 is 20 units away from 0. 20 plus 10 is equal to 30. Okay. Exercises. Order each set of integers from least to greatest. 2, 13, -11, -21, and 5. Well, -21 is less than -11, is less than 2, is less than 5, which is less than 13. Least to greatest means most negative to least negative, or most negative to most positive, or least positive to most positive. Or any combination thereof, actually, because the most positive number is the least negative number. Like, how much is 13 negative by? It's negative by -13. You start going from 0 in the negative direction, and you go 13 steps backwards. Don't actually try this at home, though, because it tends to bump into things. So, 31, 0, -34, -9, and 7. We start at the most negative, -34. So that's less than the less negative number, which is more positive, which is less than 0, which is less than 7, which is less than 31. Now evaluate each expression below. Number 3, -11 magnitude is going to be 11. And then magnitude of -5, well, it's 5 units away from 0. So 16. 4 plus -4, both magnituded, you get 4 is 4 away from 0. -4 is 4 away from 0. So 4 plus 4, which is equal to 8. So 23 plus 15, magnituded, that means we take the magnitude of the result, which is 38. So the magnitude of 38 is, of course, 38. Because how far is 38 away from 0? Well, it's just 38 units. So evaluate each expression if A is equal to -6, B is equal to 4, and C is equal to 5. Well, the magnitude of 3B is going to be the magnitude of 3 times 4. And note that if you're actually doing these questions as part of an order of operations problem, the magnitude symbols are essentially another type of bracket. Like you do the stuff inside them before you break them open and release whatever's inside to the rest of the question. So the magnitude of 3 times 4 is the magnitude of 12, which is equal to 12. 2 times magnitude of A, 2 times magnitude of -6, plus C, which is 5. Well, that's going to be 2 times 6, plus 5. So 12 plus 5, which is 17. This step here is optional once you get reasonably practiced at this type of problem, because 2 times magnitude of -6. Oh, that's just 2 times 6. Okay, 12. You could just do that. 2b plus c with absolute value symbols. Well, that's magnitude of 2 times 4 plus 5. So that's magnitude of 8 plus 5. So magnitude of 13 equals 13. Adding integers. If you add integers with the same sign, you're adding their absolute values, and the sum has the same sign as the integers. So, in this case, -3 plus -4. So you start at -3 and then you add another -4 units. Where are you going to end up? You're going to end up at, -7. If you're adding integers with different signs, subtract their absolute values, and the sum has the same sign as the integer with the greater absolute value. North American math curricula have a really funny way, in my opinion, of teaching this stuff. Because what happens if you're at +12 and then you add -16, i.e. go 16 back? So you go 12 steps forward, 16 steps back. Where are you going to end up? Oh, hey, it cancels out the 12 steps forward, and then you still have 4 more steps back to go. There are better ways to think about this or to communicate how this works than to blab about absolute values. But this is, in fact, what actually happens. Like, you are, in fact, subtracting the absolute values, because that's the part that cancels out, the subtraction. And then the sign is the integer with the greater absolute value, because that's the one that has something left. Like if you have +15, and then plus -7. Yeah, the -7 cancels out 7 out of the 15. But the other 8 are still around. So you still end up with +8. Sure, I mean, this is technically correct. But in terms of how to think about this, it is perhaps not the most brilliant feat of communication known to man. Just saying. So negative 16 plus 12. Okay, 16 back, and then 12 forward. Oh, that means we canceled out 12 out of the 16 back, so we end up with negative 4 left. Negative 4. By the way, the reason I'm using forward or up or such is that by convention, forward is positive, unless otherwise stated in a directional problem, and up is positive, unless otherwise stated. Exercises. Add. 9 plus 16 is, of course, 25. I mean, this is, what, grade 2 math? Grade 1, maybe? Depending on where you live. Because, like, as far as I understand, in China, this was grade 1. But in North America, I think it's grade 2. I think, actually, we might have done this in grade 1. I don't remember. Anyway, negative 10 plus negative 10 is equal to, well, you go negative 10 units from 0, so 10 units negative from 0, and then you add another 10 in the negative direction. You're going to end up at negative 20. 18 plus negative 26, so 18, negative 26. That means it's the same as 18 minus 26, which leaves us at negative 8. You can just open up the brackets if you like. Okay? Like 5 plus negative 4 plus 8, that's equal to 5 minus 4 plus 8. So you're leaving us with 1 plus 8, which is 9. Negative 3 plus 10 plus negative 6, that's also known as negative 3 plus 10 minus 6. So negative 3 plus 10 is going to be 7, and then minus 6 is going to be equal to 1. Negative 13 plus negative 8 plus negative 12 leaves us at, well, the negative 8 plus negative 12 leaves us at negative 20, and then we have a negative 13, so negative 33. Now, 3 plus negative 10 plus negative 16 plus 11, you can group the terms. Like, when you're adding or subtracting things, like when it's pure additions and subtractions, you can rearrange the items as long as you move the symbols along with them. So 3 positives, 11 positives, that's a total of 14 positive, and then negative 10 and negative 16, that's a total of 26 negative. So you could say this is 14 minus 26. So that would give us negative 12. Does this look reasonable? I mean, we have 3 plus 11 minus 16. So 11 minus 16 would give us negative 5, and then plus 3 would give us negative 2, and then negative 10 plus negative 2 equals negative 12. Okay. So basically checking the problem is just doing it again for most of these types of questions. Unlike, say, word problems. Evaluate each expression if x equals 4 and y equals negative 3. Okay, the magnitude of x plus y, that's a magnitude of 4 plus negative 3. So that's a magnitude of 1, which is equal to 1. Magnitude of x plus y is magnitude of 4 plus negative 3. So 4 minus 3 So 1. And x plus magnitude of y, well, that's 4 plus magnitude of negative 3, which leaves us at 4 plus 3, which is 7. Subtracting integers. When you subtract an integer, you're adding its opposite, which is its additive inverse. So find 8 minus 15. Positive 8 minus 15. Where are you going to end up? On a number line, say, because that's apparently preferred in North America. Well, okay, you can first go 8 minus 8 minus 7. And it would immediately be obvious that the 8's cancel, and then you get negative 7. Negative 7. Okay, find 13 minus negative 22. Well, that's also equal to 13 plus 22. So you can say equals 13 plus 22. The negative symbols here cancel each other out to make a positive. So this comes out to 35. Okay, then. Exercises. Let's do the subtractions. So negative 15 minus negative 12 is equal to negative 15 plus 12. So negative 3. Negative 23 minus negative 28. Negative 23 plus 28. So 28 minus 23, basically, because you can switch the orders. And that gives us 5. 16 minus 9. Oh, hey, this is something we did back in like grade 1 or 2. So that's 7. Negative 34 minus negative 46. That's equal to negative 34 plus 46. So 46 minus 34 leaves us with 12. 65 minus negative 6, that's 65 plus 6. So 71. 19 minus magnitude of 29. Well, that's just 19 minus 29. Because the magnitude of a positive value is just the value itself. So 19 minus 29 leaves us at negative 10. Okay, let's evaluate each expression here if a is equal to negative 7, b equals negative 3, and c equals 5. Well, c equals 5, so c. Minus b is negative 3, so there we go. 5 minus negative 3 is also equal to 5 plus 3, which is equal to 8. Now, b minus a minus c. b is negative 3 minus a, which is negative 7, minus c, which is 5. So negative 3 minus negative 7 is also just plus 7. I don't really like the additive inverse version for subtraction, because I vastly prefer the, hey, this is actually a coefficient of negative 1. So you have negative 1, negative 7s that are being added here. So if you multiply negative 1 and negative 7, you get plus 7. So the negatives cancel out is another way of saying it. Like when you open a bracket and it has a negative in front, you flip all the signs inside because the negative multiplies in and thus flips the signs. Like I'm sure you guys have learned how to work with brackets in the past, so yeah, same thing here, really. You're subtracting a bracket. So negative 3 plus 7 minus 5 is going to leave us at plus 4 minus 5, so negative 1. Or you can go negative 8 plus 7. C minus B minus A. Well, that's 5 minus B is negative 3 minus A is negative 7. So 5 plus 3 plus 7. So, that means you're looking at 5 plus 3, 8 plus 7. 8 plus 7 is 15. Or you could have gone with 3 plus 7 is 10 and plus 5 is 15. Because of the properties of addition and subtraction. Because what is subtraction but adding the additive inverse? Multiplying and dividing integers. Use the following rules to determine whether the product or quotient of two integers is positive or negative. The product of two integers with different signs is negative. The product of two integers with the same sign is positive. You know what this basically says? This says that if you have an even number of negatives that are being multiplied or divided together, they cancel each other out. And if you have an odd number of negatives, they don't cancel each other out, so you end up with a negative result. Because quotients of two integers with different signs, yeah, that's going to be negative, because the negatives don't cancel out. They have different signs, and if you have two integers, that means you have one negative and one positive. So the quotient is going to be negative, but if they have the same sign, i.e. you have 0 or 2 negatives, the quotient will be positive. Now let's find some examples. 7 times negative 4. We only have one negative sign. It doesn't cancel with anything, so the result is going to be negative, and then 7 times 4 is 28. Negative 5 times negative 6. The negatives cancel each other, so it's positive, and 5 times 6 is 30. Find 15 divided by negative 3. Well, there's one negative here. Nothing cancels, so it's negative, and 15 divided by 3 is 5. So negative 54 divided by negative 6, there's two negatives, they cancel. So it's positive. 54 divided by 6 is 9. Let's do some exercises. 33 divided by negative 3 is, well, there's one negative sign, so no canceling applies. Negative, and then 33 divided by 3 is 11. Negative 25 divided by 5, there's one negative sign. No canceling occurs. Therefore, we're looking at 25 divided by 5 is 5. 48 divided by 4, oh, there's no negative signs. So, it's going to be positive. 48 divided by 4 is 12. And negative 4 squared is, well, negative 4 times negative 4. There are two negative signs. So the result is going to be positive. 4 times 4 is 16. Negative 75 over 15 is, well, there's one negative sign, so negative. And then 75 divided by 15 is 5. Negative 6 times 3 times negative 5. Well, there are two negative signs. Therefore, they will cancel out, and you get 6 times 3 times 5. 6 times 3 is 18. And times 5, so 18 times 5 is going to be 90. Okay, let's think about these expressions. A is negative 1, B is 4, and C equals negative 7. So, a is -1, multiplied by b equals 4, plus c, which is -7. That's -1 times 4 plus -7, also known as 4 minus 7. So -3. -1 times -3 is 3. C squared minus 5b, that's -7, squared minus 5 times b, which is 4. So, -7 squared, -7 times -7, there are two negatives. Therefore, they cancel and we get 49. And minus 5 times 4, which is minus 20. So this is equal to 29. And a minus 6 over c, a is -1, minus 6, over c is -7. -1 minus 6 is just going to send us to -7, and this is over -7. So the negatives cancel, and the 7s also cancel, so it's 1. Same value divided by same value is going to be equal to 1 unless the values are 0, in which case it's indeterminate. Dividing by 0 is just undefined, unless it's 0 divided by 0. So, let's write some equations. Here we have some verbal phrases for each of these algebraic expressions. 8 more than a number is x plus 8. Why do we go x plus 8 instead of 8 plus x? Because it's 8 more than a number, right? Part of that's the algebraic conventions, which are that variables, especially higher degree variables. Like say if you have a squared b plus abc plus b squared c plus ab plus 5. Notice that the highest degree, because here there are 3 variables multiplied together, here there are 3, and here there are 3, because there's 2 b's and a c. And here there's 2. The highest degree comes first, and they also tend to go in alphabetical order. And the constant term goes at the end. That's for additions, though. The sum of 8 and a number, yeah, okay. Technically, you could write 8 plus the number, so x in this case, for this one, for this line. That's okay, but because addition, the order doesn't matter, we go by the convention. X plus 8, well, that's just this, just read straight out. X increased by 8, same thing. R minus 6 is this, straight out. Because in subtraction the order matters, here we have the difference of r and 6. If it was 6 minus r, you would have the difference of 6 and r for 6 minus r. 6 subtracted from a number. This is being subtracted from the number. 6 less than a number. The a number part is being used as the reference point, so that's why we write that first. 4 multiplied by n, or 4 times the number, or the product of 4 and n, or n and 4 for that matter. For multiplication, the order here doesn't matter that much. Like you could go a number times 4 and still end up with 4n, because you write the coefficient first and then the variables in every given term. Where you have a constant multiplied by a variable or several variables. Here we have a number divided by 3, the quotient of z and 3, and the ratio of z and 3. In division, the order matters very much. So you have to specify that it's a number divided by 3, or the quotient of z and 3. This order matters. If it was the quotient of 3 and z, it would be 3 over z. The ratio of z and 3. This, z divided by 3, this is equal to this. Z divided by 3 in this way, or the ratio of z to 3. So here we have some verbal sentences that represent the same equation as opposed to expression. 9 less than a number. Notice that it's a number as a reference point and it's 9 less than that is equal to 45. And the difference of a number and 9 is 45. This order matters here because it's a difference. It's a subtraction. A number decreased by 9 is 45. 45 is equal to a number minus 9. Here we could actually have used any symbol, but we used n for just arbitrarily. We could have written A or B or C or whatever, because it didn't specify the letter used for the variable in any of those expressions. But here it sure does. Write each verbal phrase as an algebraic expression. The product of 5 and B. Well, we have to use B. So that's 5B. P increased by 10. Well, that's P plus 10. 14 less than F. So we start at F and we subtract 14. The difference of 32 and X. Well, the difference of, and then you go, the first item you write down, and then minus X. That's why the order here matters. The difference of R and 6 is R minus 6, whereas the difference of 32 and X is 32 minus X. Okay, write each verbal sentence as an algebraic equation. The sum of R and 45 is 79. So R plus 45 equals 79. If we wanted to solve this, we'd get R is equal to 79 minus 45, which leaves us at 34. So, the quotient of X and 7 is equal to 13. The quotient of, that means the result of division. You don't say the product of division. It should be what is produced when you divide. Yeah, product is for multiplications. So the quotient of X and 7 is going to be X over 7 is equal to 13. X is equal to 91. The original price decreased by $5 is $34. So P, which is usual for price, minus 5 is equal to 34. P is therefore equal to $39. We should put units here because there were units in the original question. So dollars. 5 shirts sold at D dollars each is $105.65. So 5D is equal to 105.65. D is equal to 105.65 divided by 5. That leaves us with 1.13. Do we put a dollar symbol here? No. Why? Because here it said D dollars. The unit has already been given in the problem, and the variable is only the numeric value. Therefore, here we only have a number without the unit. Now, the obligatory problem-solving section that you find in chapters of North American textbooks. You can work backward to solve a problem. You use the same old four-step plan, pretty much. So let's do some examples. Mary put money in her savings account each week. She put a certain amount in the bank on the first week, so let's say, oh, this is what's required, huh? Okay, so how much did she put in on the first week? First week was X, okay? We could say this. On the second week, she put twice as much money in the bank. Second week is 2X. Third week, she put $40 less than on the second week, so 2X minus 40. Fourth week is $20 more than on the third week, so 2X minus 20. Or minus 40 plus 20 if you insist. And this is equal to $200 on the fourth week. Equals 200. And you can do the algebra, or you could have solved this problem by going fourth week, $200. Third week, well, it was $20 less than on the fourth week, so $180. Second week, oh, third week she put $40 less. Okay, the second week must be $40 more than the third week, therefore $220. First week, then divide by half because second week doubles that. That would have been actually working backwards. Here, though, we assess the problem and we listed what was given to us, and we can just solve. So 2X is equal to 220. So this is $110 on the first week. She put in $110 on the first week. Okay, let's say, oh, here it actually says, use the work backward strategy. Okay, then we will work backward. Fine, whatever. Jack brought a total of $95 when he went shopping for camping supplies. He spent $39.99 on food, $24.49 on a sleeping bag, and bought lunch. When he got home, he had $15.70 in his wallet, and 35 cents had fallen loose into his pocket. How much did he spend on lunch? So if we work backwards, we have plus 0.35 equals, yeah, okay, you might as well just make this a vertical. 0 and then 6 and 1. Okay, so this many dollars at the end of the day, and this was after how much spent? So he bought lunch. How many dollars? We don't know. And he had $95 beginning. And he spent $39.99 on food minus $24.49. So in total, that was minus how much? So 48, and then 64. Okay, so he spent $64.48 before spending some money for lunch. Hey guys, this value is pretty close to 65. Therefore, you could just go with minus 65 and then plus 0.52. So that would leave us with 30.52. And he spent some money for lunch, and he had $16.05 left. Therefore, lunch was equal to 30.52 minus 16.05. So 30.52 minus, oh wait, why am I doing this? No need for a calculator, really, because, 0.52 minus 0.05. I wonder what happens. Okay, that's 47. And then 30 minus 16 is just 14. So it's $14.47 for lunch. So he spent $14.47 on lunch. I recommend using work backward strategies only when working forwards is really awkward for some sort of problem. Okay? Like a lot of the time, like such as in this problem, it's more trouble than it's worth, really. Robert is 4 years older than Eric. Eric is 8 years younger than Jing. Jing is 4 years older than Darlan, and Darlan is 15 years old. How old are each of the others? Well, Darlan is 15. Darlan, 15. Jing is 4 years older than Darlan, so Jing is... we're going backwards in terms of the order they're presented in the problem. But I kind of have my doubts about whether this problem actually qualifies as working backwards. Eric is 8 years younger than Jing, so 19 minus 8 is 11. And Robert is 4 years older than Eric. That means he is 15. There, we have given the answers by working backwards, quote unquote. Addition and subtraction equations. You can use the following properties to solve addition and subtraction equations. If you add the same number or subtract the same number from each side of an equation, the two sides remain equal. Actually, if you do the same thing to both sides, unless you divide by 0, they will remain equal. So, example 1, solve w plus 19 equals 45. Check your solution. W is equal to 45 minus 19. So that's 26. Because you can go with minus 20 plus 1. So it's 20. W equals 26. Yeah, you should restate it at the end of when you're equaling a final value. Even if you just stated what it was. Literally the line before. It's just a convention that many people like. Check your solution. Well, how do we check it? Left side is equal to 26 plus 19, which is equal to 45. Left side equals right side. Therefore, quod erat demonstrandum. What is asked has been shown. Okay, example 2. Solve h minus 25 equals negative 76. Check your solution. Hey guys, what do 25 and 75 relate? How do they relate with each other? What about 76? It's really close to 75, isn't it? So, h is equal to negative 76 plus 25. I mean, you can think of this as moving this over and changing the sign, or you added 25 to both sides and this side just canceled. So we didn't write that out. If your teacher wants you to write it out, by all means, do what your teacher says, because your teacher marks your stuff. So negative 76 plus 25 is going to end up with 25 minus 75 is equal to negative 50, so minus another 1 is negative 51. h equals negative 51. Okay, then. Exercises. Solve each equation and check your solution. So s minus 4 is equal to 12. S is equal to 12 plus 4 equals 16. Left side, 16 minus 4 equals 12. Left side equals right side. QED. That's how checking works. You prove that you substitute your results into the original thing and that things match up. The left side and right side are equal. So d plus 2 equals 21. Look, you can write 21 minus 2, but really here you can just go with 19 as far as I'm concerned. The left side is equal to 19 plus 2 equals 21 equals right side. Therefore, QED. h plus 6 equals 15. h is equal to 15 minus 6, or just 9. So left side is equal to 9 plus 6 equals 15 equals right side. Therefore, QED. So 19 equals z minus 32. So you can go z equals 19 plus 32 and then rearrange on the next step, which would leave you at 32 plus 20 minus 1. So 52 minus 1, 51. Yeah, there are many shortcuts to doing simple addition problems, just saying. So z equals 51, and then you would go right side is equal to 51 minus 32, which is equal to 19, which is equal to left side. Therefore, QED. Or you could have moved that over and flipped the sides in one step. Okay, like the first line could have been z equals 19 plus 32. So it's kind of up to choice. So, and also, how comfortable are you with rearrangements? T is equal to negative 29 minus 13. So, also known as negative 30 minus 12. Yeah, this is kind of what you would expect after, well, the first couple of times that you showed your teacher, yes, you know what you're doing. Can you please stop demanding all of these written out steps. Of course, negative 29 minus 13 is actually still a pretty reasonable step compared to 13 plus t minus 13 equals negative 29 minus 13. Yeah, no, that's like... But wait, though. Just to show the rule that if you do the same thing to both sides, the same thing, there's going to still be equal. Anyway, this would be left side, because that's where t is equal to 13 plus negative 42. So that's negative 29, which is equal to right side. Therefore, that's QED. 55 equals 39 plus K. That's going to be K equals 55 minus 39. See, we can do the rearrangement right off the bat. And then K is equal to, what's 55 minus 40? Oh, that's 15. Okay, minus 39 is going to be subtracting 1 less than 40, so 15 plus 1 is 16. So, right side is equal to 39 plus 16, which is equal to 55. Equals the left side. Therefore, what's been asked has been shown. We've checked this thing. As I said before, for multiplication and division equations, same thing applies. You do the same thing to both sides of your equation, whether this is taking it to some exponent, or taking it to some radical, or multiplying or dividing, and the sides will still be equal unless you divide by 0, in which case, no, don't do this. You may get undefined or indeterminate. Indeterminate is if one side of the equation is 0 already. And undefined is if both sides are not 0 to begin with. Example 1. Solve 19w is equal to 114. Well, w is equal to 114 over 19, which is equal to 6. So w is equal to 6. How do we check this solution? Left side is equal to 19 times 6. So that is 114, which is equal to the right side. QED. Solve d over 15 equals negative 9. Well, d equals negative 9 times 15. You can say that you multiplied this over. Or you can say that you multiplied both sides by 15. It's just two different schools of mental simplification. So d is equal to 9 times 5 is 45. 9 times 1 is 9, so negative 135. So check your solution. Left side is equal to negative 135 over 15. Hey guys, what's 135? Oh, it's 150 minus 15. So we're looking at negative 9 here, because this is negative. And that's equal to the right side, which means that you've shown that your solution is correct. Solve each equation and check your solution. R over 5 is equal to 6. R is equal to 6 times 5. Which means R is equal to 30. Check your solution. Well, left side is equal to 30 over 5, which is equal to 6. which is equal to the right side. Hurrah! Therefore, QED, what's been asked has been shown. 7h equals negative 21, while h is negative 21 divided by 7. Or you can say that 7h over 7 is equal to this, but really, who wants to do that much writing? So, negative 21 divided by 7 is going to leave you at negative 3. And to check this, left side is equal to 7 times negative 3, which is equal to negative 21, which is equal to the right side. Therefore, what's been asked has been shown. Now, for negative 8x equals 40, while x is equal to 40 over negative 8, negative 8, so that gives us negative, because there's one negative symbol among here, and 40 divided by 8 is 5. So left side is equal to negative 8 times negative 5, which is equal to 40, which is equal to the right side. Therefore, what's been asked has been shown. And x over negative 10 equals negative 7. X equals negative 7 times negative 10. So negative 7 times negative 10, the negatives cancel each other out, and therefore 7 times 10 is 70. And left side is 70 over negative 10. So there's one negative here, therefore the result is going to be negative. And 70 divided by 10 is 7, which is equal to the right side. Therefore, what's been asked has been shown. Okay, so a few more examples here. 17c equals negative 68. C is equal to negative 68 over 17. Now 17 times 2 is 34. 34, 68. They look like they're related because 68 is twice of 34. There's one negative sign here, so it's negative, and it's going to be 4. So left side is equal to 17 times negative 4. So negative 68, which is equal to the right side. Therefore, QED. What's been asked has been shown. 29t is equal to negative 145. Well, t is equal to negative 145 over 29. So t is, first of all, it's negative because there's one negative symbol here. And 5. Now the left side is 29 times negative 5, which is going to be equal to 30 times negative 5 minus negative 5. So 30 times negative 5 is negative 150, and then plus 5, so negative 145, which matches up to the right side. Hurrah! That means that our answer was correct. Okay, so let's say 125 is equal to 5z. Well, z is equal to 125 over 5, which means it's equal to 25. Z is equal to 25. Right side, because that's where z is at the beginning, is equal to 5 times 25, which is 125, which is equal to left side. Therefore, right side equals left side, or vice versa. You've shown that what's been asked is true, or what you're checking is correct. 117 and 39k, well, k is equal to 117 over negative 39. So 120 over 40 is 3. 117, which is 120 minus 3 over 40 minus 1, is going to be, well, first of all, it's negative because there's one negative sign here. That's also 3. So k is equal to negative 3. Now, the right side is where k is at the beginning. So right side is equal to negative 39 times negative 3, which is equal to 117. And this is equal to the left side. Since the right side equals left side, QED. What's been asked has been shown. So, if you do the same thing to both sides of an equation, you end up with the equation still being true. Well, your new equation still being true. This chapter is hopefully all review for you guys. So, that's it. See you next chapter.